So today we got a hard problem 878, nth magical number. A positive integer is magical if it's divisible by either a or b. Given three integers, returning natural this. So either. Does it mean that it can be divisible by both? Okay, looks like yeah. So 2, 3, 4. I mean, that's just the answer may be very large, so 10 to 9th number, and if this is 10 to 4, then could be like 10 to 15, I think most. So nth number, so we want to find like I mean, this is inclusion exclusion, so let's say we pick first 10 divisors of this and then first 10 divisors of this, and then subtract the number of okay, I think we can do this with binary search. So not sure the number really will be larger than 10 to 18 or even less. So basically we are going to do binary search and count numbers that are smaller than this, and then get like, so like, okay, let's say we ask is 100, so how many numbers smaller than or equal to 100 are divisible by either a or b? Well, it's 100 divided by 2 plus 100 divided by 3 minus 100 divided by 2 times, or like LCM of that, right? So that's yeah, LCM of those two numbers, which is yeah, because we want divisible by both of them, and if it's divisible by both of them, it should be divisible by their LCM, which is a times b divided by GCD. So let's say there is 10 numbers and we want only 4, then we know we have to decrease the number by 1. And if we have smaller than or equal to, no, if what we got was larger than or larger than or equal to, we want to adjust the lower bound, and if we got something smaller, we want to increase lower bound by 1, and then we get log of whatever that max number is, and that max number should be like, I mean, worst case both are this large number, so you have, and n is 10 to 9, so you have to multiply like 1, 2, 3, 4, blah blah blah, right? But wait, that might be too much. No, just times 10 to 9, because if we want like fourth number, we do 4 times 2, so we do n times whatever the larger is. Okay, that's fine. So long, okay, can it be, probably it should not be 0, so first number 2, so L is 1, R is, I don't know, 1E18, while L under R mid is this, and now CA MA. Well, let's just do like count is M divided by A plus M divided by B minus M divided by, and this is A times B, or like there, AB LCM, AB LCM is equal to A times B. I mean, that should fit into int, because 4 times 10 to 4, so that's 16, 1.6 times 10 to 9, and it should be like 2 point something for ints, and for unsigned 4 point something. So this, and now if count is less than n, then okay, and finally we do return L percentage 1 in 9 plus 7. Almost. Okay, and that was easy, I think. Binary search. The answer can be at most max AB times n, which is at most 4 times 10 to 13, I think. First observation is that the answer can be at most this. Now let's say we pick a number x. How many numbers divisible by A or B are smaller than or equal to x? Well, from the inclusion exclusion principle, it's x divided by A plus x divided by B minus x divided by LCM AB, where LCM AB is largest common multiple of x of A and B. In other words, in plain English, this means it's the number of multiples of A plus the number of multiples of B minus the number of multiples of both A and B, where the last is exactly LCM AB. Now only thing we need is to binary search. Now that we know how to verify, let's put this into approach. That a number x, how to check A or B divisors, multiples like this. Of we can simply do a binary search for the answer, and for each mid we check how many divisors of A or B are small, are like limit. Let it be tsund. If tsund and we need more, the answer is over x, otherwise the answer is we adjust the search interval accordingly. Okay, so that's log of n max AB log n plus log max B. I think that works. 1 2 1 2 3 2 1 0. That's fair. Time complexity. Since we do binary, since we first compute the LCM of A and B, which is just AC dot B frac this GCD AB can be computed in O log max AB using standard Euclidean algorithm. And we do binary search in range 1 and C dot max AB. Therefore it and for each iteration we do O1 calculations, and there is O log nc dot max ab equal to O log n plus log max ab iterations. Space complexity is O1 since we only store the LCM of A and B and a couple of extra variables for the binary search. And then maybe I should change this to like n times max AB. Maybe that will work. Not sure. I will try. Let's see. Oh, 1ll times this. Okay. So let's update my whatever. Nice, and now let's see what's the real solution. Oh my god, what? That is crazy. What's R? What is R? Remainder is n percentage m. Approach to is log. Okay, that's fair. So how do they math this out? Oh, okay, that's a stupid trick. Okay, I mean, okay. So the point of this trick is that you count numbers, so from like 1 or whatever to LCM of A, B, there is like L divided by A plus L divided by B minus 1 divisors, right? So, and then we want, so there is, let's say there is like X of them, so we wanna like just count these until we get until X times Y for some Y is smaller than, or for maximum Y is smaller than or equal to N, and then we just iterate like over who cares what, we just iterate the rest. Fair enough. Okay, I mean, but that's slow actually. That is very slow, bruh. Couldn't it be done faster than O of A plus B? I'm not sure, and I don't care. The binary search is faster, so who cares? Okay, let's see their binary search. I never understood this calculation. Why would you do it like this? That's fair. I mean, this is dog water way of writing it, but fair enough. Okay, who cares? Goodbye.